Hello everyone, I am Mrs. Shumala Hassan, Department of Humanities, the Bhopal School of Social Sciences. In traditional production theory, the factors used for production are known as the four factors of production, that is land, labor, capital and entrepreneur. These four factors of production are also called as inputs. Now the term output means the unit of products produced with the help of the inputs given the constant state of technology. So therefore, the traditional production theory deals with the problems of combining the inputs optimally in order to get a stipulated output with the given state of technology as constant. In this module, we are going to deal with the traditional production theory, the laws of return, that is, the types of production function, and lastly, we are going to deal with the concept of total product, marginal product and average product. Like we have already taken up in the introductory part, output is the term which means the total units of product produced with the help of inputs. So therefore, we require a technical relationship in order to define that how much input would be required to produce a stipulated output. Production function is a technical relationship between the amount of inputs and the amount of output that is required during a production process. In the words of Professor Stigler, the production function is defined as a technical relationship between the rate of input and the rate of output. It goes on to explain that if at a rate input changes, by how much is the output going to change in the production process. As already discussed, production function is the technical relationship between the inputs and the output. It tells us as to what extent the stipulated output is going to change if we make any changes in the proportions of inputs to be used. Algebraically, we can express the production function as Q is equal to function of M, N, C and T dash. Now let's understand what all these variables stands for. First and foremost, Q stands for the total output to be produced, F states the functional relationship, L stands for labor, M stands for management and entrepreneurship, N stands for the natural resources or land as we call it as a factor of production, C stands for capital and T bar stands for the given constant state of technology. So therefore, what do we mean by a functional relationship here is that the output Q is going to change with every change in any of these factors, only the technology remaining constant. Usually economists find it a little difficult to represent a combination like this of so many inputs with the related output. So therefore, they prefer taking a two-input model to explain the production function, or we can say the technical relationship between the inputs and the outputs. Now, if we represent this relationship on a graph like this, taking only two inputs at a time, let us take the labor and capital. So therefore, your graph is going to look something like this. This is going to state a technical relationship between the output and input. Here the inputs that we have taken are only the capital and the labor. So how is our production function going to algebraically look now? It is going to be Q is going to be a function of L comma C. That means here in a two-input model, if labor changes or capital changes, then there is going to be a confirmed resultant change in the output also. Here we can take labor and capital, and here on the y-axis we take the total amount of output. Production function is usually defined in relation to the technical requirements or the technical conditions of a production process. Sometimes the technical conditions prevailing in a production process are rigid and sometimes they are flexible. If we are talking about rigid technical conditions of the production process, we mean that there is some kind of a rigidity in changing the combinations of input with respect to the output. Here we are referring to the short run production function. In the short run production function, it is very difficult to change all the inputs required for production at one go. That is the reason here there is a possibility that we change only one particular input in order to maximize the output, but keeping all the other inputs as fixed. So here we define clearly what is the meaning of a variable input and what is the meaning of a fixed input. The variable input refers to the input which is required for production, which can be changed in the short run. In the short run, we have two types of inputs, fixed inputs plus the variable inputs. The short run production function aspect is known as the law of variable proportions. Now let's talk about the technical conditions which prevail during a production process that are flexible. Now by what do I mean by flexible production conditions? That means I am in a position as a producer to change all my inputs pertaining to the resultant output. That means I am in a position to change the scale of my production altogether. This is referred to as long run production function, where the producer is in a condition to change all the inputs with respect to a stipulated output. The long run production function aspect is known as the returns to scale. So let's revise. There are two types of production function pertaining to the technical conditions of production process. One is rigid, another is flexible. The rigid one is known as the law of variable proportion, which is the short run production function, and the long run production function, or the flexible one, is known as the returns to scale. So let's discuss a little bit more about the returns to scale. The returns to scale are of three types: constant return to scale, increasing returns to scale, and the diminishing or decreasing returns to scale. Now let's talk about the constant return to scale. If the change in the output is exactly equal to the proportional change in the inputs, that means if the inputs are changing by two-folds and similar to that exactly your output is also changing two-folds, then it is a constant return to scale. If your inputs are changing two-folds but the resultant output is changing by 4 times, then it is an increasing return to scale. And if your inputs are changing by two-folds but your output is becoming half, two-folds and half, that is the comparison here. So therefore we can say that it is a decreasing returns to scale. So let's revise the constant return to scale with the help of our production function. Okay. Let's say if we are increasing all these inputs by n folds, okay, n is a constant, and if we are increasing all our inputs by n fold, with the help of the constant return to scale concept, we can conclude that your output is also going to increase by n fold. So therefore your equation now will be n times of q is equal to function of n times L, n times M, n times N, n times C. We are not going to include the T bar here because the state of technology remains constant. So therefore this is an example of the constant return to scale. This is known as a linear homogeneous production function. Now let's say for instance this particular n is raised to kth degree. Again your k is going to be a constant here. Okay. Now let's understand this relationship. If k is equal to 1, that means here if k is equal to 1, it is again going to take the form of a linear homogeneous function. So therefore when k is equal to 1, it is a case of constant return to scale. If k is greater than 1, then it is a case of increasing returns to scale, and if k is less than 1, then it is a case of decreasing returns to scale. Now, to have a more clarity on this particular production function, let's take the two values of n and k. Okay, let your n be equal to 2. Okay, and in the first case, let k be equal to 1. In the second case, let k be equal to 2, and in the third case, let k be equal to -1. So, as explained previously, we are going to consider the values of k equal to 1, k is greater than 1 and k less than 1. Okay. So, in the first case, n is equal to 2 and k is equal to 1. So, what is the expression here then? 2 raised to the power of 1 multiplied by the output quantity, then function of 2L, 2M, 2N and 2C. We are leaving out the constant state of technology here. So, therefore, what can we conclude? 2 raised to the power of 1 is going to be 2. So, your output has doubled with doubling of all the inputs. This is a case of constant returns. Okay, 2 times output, 2 times inputs. Let's take the second case. Okay, in the second case, we have taken the value of k is equal to 2. That means k is greater than 1. So, therefore, here n is 2 raised to the power of 2 multiplied by q, that is the quantity of output, is equal to function of again 2L, 2M, 2N and 2C. Here clearly this can be stated as 4, right. So, therefore, 4 times output but only doubling of inputs. So, this is a case of increasing returns. This is a case of increasing returns to scale. Now, let us take the third case in which the value of k we have taken as -1, which is less than 1. Third case, k here is -1, n is 2. So, 2 raised to the power of -1 multiplied by q, that is the quantity of output, function of again 2L, 2M, 2N and 2C. 2 raised to the power of -1, any natural number raised to the minus power will be, the value of this is going to be 1 by 2 q is equal to function of 2L, 2M, 2N and 2C. So, here we can clearly see that doubling of inputs has caused the change in the output, which is exactly the half of the output that we require to produce. And finally, this is the third stage. So, here we were dealing with the production function, which is a technical relationship between the inputs and the stipulated output. So, to understand this more clearly, let us go on and revise this once again. So, this is a production function raised to the kth degree. Here, let us take an example for n is equal to 2. First case, k equal to 1, that is k is equal to 1 linear function, k is equal to 2 and k is equal to -1 in the third case. First case is explained here, n is equal to 2 raised to the power of k. K here in the first case is 1. So, 2 times q, function of 2L, 2M, 2N, 2C. These four are the inputs. So, this is the case 2 where your n is equal to 2 and k is equal to 2. 2 raised to the power of 2 is 4, 4 times q as a result of function of 2L, 2M, 2N and 2C. That means doubling here and the output is 4 times. Third case, k is equal to -1, n that is 2 raised to the power of -1 multiplied by Q is a function of 2L, 2M, 2N and 2C. So that means first case is a case of constant return where we are getting equal returns on output. Second case, increasing return where doubling is causing the output to become 4 times. And the third one is a case of decreasing returns to scale where the doubling of the inputs is causing the output to become half. So here we can conclude that the production functions can be of 2 types. The first one is the linear homogeneous function and the second one is the non-linear homogeneous function. Your linear homogeneous function will be of a type where your k is going to be equal to 1. That means the change in the input will cause exactly same proportional change in the output, and the non-linear homogeneous functions will be the one where your k is either greater than 1 or it is less than 1. We had taken the 2 examples in the previous section. Another very important type of a production function is known as a Cobb-Douglas production function. We usually call this as a CD production function. Okay. This is known as a Cobb-Douglas production function because it was developed by Charles Cobb and Paul Douglas between the period of 1927 and 1947. This production function was first experimented in the American manufacturing industry, but it also can be generalized for an economy as a whole or any one particular sector of any economy. The CD function algebraically can be expressed as A times the output is equal to capital A times the capital raised to the power of small a multiplied by labor raised to the power of 1 minus a. Here A and capital A are constants. The exponents of C, that is capital, and the exponent of L, that is labor, both of them should add to 1. Okay. In the further sections, we will go on to elaborate the Cobb-Douglas production function also. Now let's go on to explain the 3 most important concepts in order to understand the production function. These 3 important concepts are the concepts of total product, marginal product and the average product. Okay. Now let's have a look at this word product here. This product is nothing but we have another word for output, that is product. Okay. So by product here you will understand the term output is interchangeably used with the term product. Okay. So let's see how can we calculate these 3 important concepts. So first one is the total product. Now the total product is nothing but the total output produced, that is Q, and Q is a function of L. Here L is nothing but your variable input in the short run which is going on changing. Therefore Tp is equal to Q and expressed as a function of L. Okay. Marginal product, please remember in economics marginal means plus 1. So therefore here marginal product of L units of variable factor can be defined as change in the total product divided by change in the variable input, that is labor. In simple terms, we can also explain marginal product as addition to the total product when one more unit of a variable input is used in the production process. I repeat myself, marginal product is nothing but the addition to the total product when one more unit of a variable input is used. Okay. Let's go on to explain what average product means. Now the word here is average. Average means the mean. Okay. So therefore average product of L units of variable factor can be calculated as total product divided by the number of variable inputs used. We can also say that average product is the product produced per unit of variable input. So let's have a quick recap of this module. First we went on to explain what exactly is production function. We described production function as a technical relationship between the inputs and the output. Then we explained the different types of production function. The different types of production function were the short-run production function. The short-run production function is known as the law of variable proportion. The long-run production function is known as the law of returns to scale. And then we elaborated on the Cobb-Douglas production function. And lastly, we saw that what are the concepts of the total product, marginal product, and average product. In our next module, we are going to deal with the two most important laws of return, the law of variable proportion and the laws of return to scale.